Good morning, and thank you very much for the opportunity to share with you a project that I'm extremely passionate about, and also something that we did this year to take up the challenge of COVID-19. I just need to mention the YES project, sponsored by entities from Germany, which is part of a collaboration between us, Namibia, Mozambique, and German colleagues, and this project forms part of this collaboration. Before I start, just a kind of a disclaimer to get rid of my feeling of inferiority, talking to a bunch of researchers that do very high processing machine learning coding, and I'm talking to you about something kind of equivalent to building puzzles. So in a way, I feel like a grade art teacher talking to teachers teaching matric maths, but I'm sure I'll be able to convince you that this is relevant to everyone that's part of machine learning research in the country. So I hope that when you listen to me, you will understand that I'm part of your skills pipeline. The research in very high level coding in South Africa and in the world is dependent on getting new people coming in as first years as software developers. And that's where our focus lies. I don't think I need to convince any of the listeners to this talk of the desperate shortage regarding software developers in our country. As a professor in programming at our university and involved with engaging with industry, we sometimes weekly get emails or telephone calls from industry partners desperately looking to employ software developers. In our home city, I, for example, know of one company who has to fill 26 new software developer posts by the end of this year. In East London, there's a global corporate that for the past year or two have been trying to fill 50 new software developer posts. And I may call it pipe dream, is that these graduates all must be M or PhD graduates. We are all very aware that our government understands this, and that our president and some of his cabinet ministers often talks about the fourth industrial revolution and their plans to address these issues. We are also aware that they want to bring in coding and robotics into our primary schools as subjects, and they actually had plans to roll it out to 1,000 schools in 2020. But there's a reality check for government and for all of us. And many of my students over the past years have often reminded me of this. Of the 26,000 schools in our country, 15,000 do not have their own computer laboratories. And the government has estimated that it will cost on average R1 million per school to equip schools with computer laboratories. But the challenges go much further than just infrastructure. I think we will all have a sense that most teachers are simply not equipped to teach coding and robotics. A lot of the content for coding and robotics is not adapted yet for the South African context and still needs to be localized. Schools need technical support. Many of us are aware of labs that were installed in schools and that are simply not functional because there's no technical support. And then living in South Africa, the safety and security issues related to PCs and laboratories is huge for schools. So when my student and myself set out on a project in 2017 to introduce coding to learners, especially from disadvantaged communities, we had the following additional objectives. We said to ourselves, there's no ways that we can be dependent on expensive computers or robots. We definitely wanted to expose learners and make them aware of careers in software development. And there's no ways that it would have worked if it was not fun. So in 2017, Byron Batterson, an honor student in our department, developed the Tanks app that makes use of mobile phones, customized tokens, and image recognition to allow learners to build code with their tokens and then to see it execute on the screen. So the basic idea is that you need to move a tank on the screen to a specific destination. You then use your tokens to build your code on your table or on your surface. You take your phone and you take a photo of these tokens. Through image recognition, the tokens are internalized and are then executed, moving the tank on the screen. The coding concepts that are introduced through this game are the concepts that I would be teaching my first year programming students in their first 6 months, which includes loops, the for loop and the while loop, the if statements, nested loops and constructs, as well as optimization of code. Because we have 35 levels of increasing complexity, the whole concept of gamification also kicks in when learners start playing, and therefore it is always huge excitement and great fun when we have workshops with tanks. Tanks was our original app developed in 2017. Since then we've developed 2 further coding apps. The one is Rangers, with a additional theme of game poaching in Africa. And then Boats focuses on marine pollution. And we've just added another content to Boats which focuses on renewable energy. All 3 of these apps introduce coding concepts, but the later 2 also now have environmental emphasis. So since 2017, we've been presenting workshops across the country and also in some other countries, and we estimate that we've reached way over 20,000 learners through these direct workshops. In addition to this, there's also the learners that played the games at their schools and other events that we were not involved with. I have many stories of individuals' lives that were impacted over these 3 years. I guess there are many that I don't know of, but just one story is Tulumanku, who stays in Zwide Township in Port Elizabeth. At the end of 2018, we had a national championships at Sandton Convention Centre, where he came 7th in the country. We later managed to get him a sponsorship from Dimension Data, and he's now studying at Alexander Road, one of the top IT schools in our province. He will be doing IT from next year, and he's well on track to study BSc Computer Science after matric. During mid-2019, we introduced our school kits, which includes lesson plans as well as instructional videos and other resource material that are aimed to equip and empower schools and teachers to start their own coding clubs in their schools without needing a computer laboratory, just by playing our games. Since June last year till about February this year, we probably distributed way over 100 school kits to schools across the country, and teachers were all ready to go and to start implementing it in 2020. But as we all know, end of March, COVID-19 hit South Africa and everything came to a grounding halt. Also for our interactive workshops, for the plans teachers had to introduce tanks and rangers in their schools. All of these were dependent on interaction, kids touching different puzzle pieces, interacting with each other. So all of this was immediately put on hold, and we went into 2-3 weeks of limbo, not really knowing what to do for the rest of the year. So after not really doing much for the first 2 or 3 weeks, I said to myself, but we need to come up with a new strategy, otherwise 2020 will be totally lost. So the realities was that we need to do something, but no physical interaction was possible. So we couldn't rely on physical tokens. Learners physically had to play at home. There was no ways of getting them into a hall, into a workshop. Teachers were totally overburdened and stressed, so whatever we planned had to mean as little as possible effort for the teachers. We really wanted to make a positive impact during the pandemic and not just be a nuisance to schools. We said to ourselves, it must be fun. And many teachers told us that learners were craving for some fun activities during this very unnatural year. And then we also needed incentives just to get the learners interested. On a bigger scale, we said to each other, and I think many projects had to say this to themselves for 2020, that although we in a natural state, we needed to stay in the hearts and minds of people. So when we go back to normal somewhere in the future, they must still know about our games and the impact it can have. So we came up with a virtual tournament using our Boats app where kids could play from home. In the Boats app, you need to move around a boat on the grid with the same commands: move forward, turn left, etc., to remove plastics from the ocean. So the first change we made was that learners were allowed to toggle their commands on the screen and therefore didn't need any physical tokens to play. To add to the information content and awareness, while they play boats, they get tips about marine pollution and also different multiple choice questions related to the themes. So themes, in addition to marine pollution that we had this year, were COVID-19 health issues, and in September also just interesting South African heritage facts. We are planning a global tournament in January, which will add the theme of renewable energy. In the aim of having as little of effort from the teacher's side, we simply prepared this one-page flyer, which was emailed or WhatsApp to the teachers, and then all they needed to do was to forward that to their learners. Most schools were in online learning mode, so getting online contact with their learners was not a challenge to them, and there was nothing else expected from teachers after forwarding this flyer. We were really blessed by wonderful corporate sponsors, because corporates were also looking for a way to make an impact where the normal things that they invested in weren't possible for this year. So we made great strides in getting corporates on board. So we presented 3 virtual tournaments during 2020, reaching around 1,000 learners, 180 schools or NGOs, and the learners in total submitted over 30,000 scores to a central database. For every tournament, we targeted a specific a social enterprise that benefited from the tournament. The first one was serving coffee to medical staff in the hospitals in Port Elizabeth. Then we also sponsored Sangkop, that saves seabirds at the Port Elizabeth Ocean. And our last project aimed at buying shoes for learners that were impacted by COVID-19. In total, around 40,000 worth of incentives and donations went towards social entities. The learner incentives were obviously very popular with the learners. This included mainly free data, which was very relevant for 2020, also some cash prizes and tablets for the winners, and that was worth over 25,000 Rand. As an investment in the future and giving us something to do once we're back to normal, sponsors also sponsored 36 school kits that were distributed to schools and NGOs across the country. A direct outflow from the virtual tournaments are 3 coding clubs, physical coding clubs, that started in Hazyview, in Tsomo, in the rural Eastern Cape, as well as in Port Alfred, where learners are now coming together once a week to do some coding using our apps. We obviously also now have a huge network, not only of teachers, but also of learners having their email addresses and cell phone numbers, which gives us a wonderful network to reach out to them in the future. And we've also started a partnership with SMS Portal, which will allow us to communicate with learners and teachers at no cost. Being a first-year lecturer, I obviously had to make online videos for my first-year students regarding the introduction to coding. So this made us think that once we had all these learners that participated in the virtual tournaments, we could start with coding clubs. So what we did is we used WhatsApp to send my videos to them, And in this video, the coding club ran for 4 weeks. The learners were introduced to data types, input and output, loops, and if statements for the C# language. We also identified an existing app which allowed them to do compilation on their smartphones, so they didn't need computers or labs to play with. We estimate that about 30 learners will complete in total our first and second coding club. And what's really exciting about this is how positive these learners were and are about coding now. Many have said that this has opened their minds regarding future career choices. Talking about being in the hearts and minds of people, we had wonderful media coverage in local newspapers, journals, as well as radio throughout the year. But this had an additional spin-off. It's not just about our project. In all this media coverage, the message of the shortage of software developers was portrayed and given through to the public. So on a bigger scale, we had a huge success in making the public aware of the shortage of software developers, and hopefully that will convince more parents and teachers and learners to consider this as a career choice. I always end off my talks with this story about Yolanda Jordan, who grew up in Mount Frere, rural Eastern Cape. In grade 9, in a school with no computers, she read the Da Vinci Code by Dan Brown, in which they talk about algorithms and cloud computing, and that started her dreaming about one day studying computer science. 4 years later, she enrolled for a degree in our department. And this is the main aim of our bigger project, to get learners to start dreaming about a career choice in software development. To stay up to date with our projects and what we do, you're welcome to join us on Facebook, Games Powered by Tangible, and you're also very welcome to email me if you want to find out more. We are now open for questions. Thank you very much. Okay, I'm ready if there were any questions. I'm not sure. I saw one question on the chat while we were busy regarding corporate sponsors, and that is our main way of doing this, getting corporates to sponsor the games that we then take into schools. Because obviously our main target is disadvantaged schools and disadvantaged communities that cannot afford to buy our games from us. But we've also sold the school kits to probably around 50 of the top schools in the country. Many of them are IT schools, and they aim to use it mainly in grade 9, or primary schools that use it at primary school level. I don't see any other further questions, or maybe there's one now. Yeah, thanks for the comment, Werner. Appreciate that. We're very excited, and our bigger dream is obviously to, I think we have the tool to go into the whole of Africa. Some of you might know of Africa Code Week that reaches a few million kids per year in October, but they're reliant on stuff like Scratch that needs a computer laboratory, and these days connected computer laboratories to the internet. And I really believe we have a tool that can reach a much bigger footprint across our continent. So we continuously knocking on doors for corporates and mainly global sponsors so that we can take this much bigger. Okay, then I think I will sign off. You did see my email at the end. You're welcome to contact me privately. Thank you very much.
Thank you very much, Professor Grelen. I'm also very pleased to see that such an encouraging and fascinating talk was complemented by a complete devouring of all the snacks that I brought along. We're going to stick to time, and we will return at 10:30 for the next talk by Professor Liesl Cilliers, entitled 2 Decades of African Research on Academia Industry, High Performance Computing Access and Utilization. Oh, sorry, 11:30. I've just been corrected. And in the interim, I will replenish the snacks for the next session. Thank you. Welcome back. Our next talk for this session will be by Professor Cilliers from University of Fort Hare, titled 2 Decades of African Research in Academia, Industry, High Performance Computing Access and Utilization. And as before, please remember to post your questions in the Q&A box, and we'll reserve the final 10 minutes of the session for Q&A. Thank you.
Okay, good morning, colleagues. Thank you for having me. I just want to make sure if you can see the screen. We're all good?
Yes, we can see it.
Okay, so good. Thank you. Good morning, ladies and gentlemen. Thank you for the opportunity to present our research to you today. The title of the presentation is African Research on Academia, Industry, High Performance Computing, Access and Utilization, a Systematic Literature Review. Just see how I go to the next screen. Sorry, colleagues, I'm just trying to flip over to the next one, which I'm not quite sure how to do at the moment. Oh, there we go. The study is part of a bigger research project that is sponsored by the CSIR and HPC. As you can see, there are several researchers from 6 South African universities working together on the project, which is very exciting. Prof. Willie Chinamarundi from the University of Fort Hare is the PI on the project. This study I'm presenting today is part of a doctoral study and presents the very first steps in the literature review to understand the problem around how academia and industry access, share, and utilize HPC resources. For the study, we were not so much interested or concerned in the outcome or results of the various HPC projects in Africa, but rather how the HPC resources are managed and shared. Thus, the study represents the initial literature review of the PhD student. If he has missed any important studies, please share those with us via the emails that will be available at the end of the slideshow. HPC is still a relatively new field in the information system context, but it is much more established in computer science, where supercomputers are used to process data by aggregating computer power to perform complex calculations at high speeds. These tools enable data collection and interpretation, scientific discoveries, and new innovations to improve the quality of life around the globe by means of scientific, industrial, and social advancements. Examples include research labs, where it is used in aeronautical design and prototyping, new uses in renewable energy, while in healthcare it can be used to improve diagnostic processes, bioinformatics, including DNA sequencing, and new drugs. HPC can help to solve abstract theoretical physics problems and generate simulations of stars and solar systems for astrophysicists. Weather patterns, earthquake simulations, test scenarios to monitor supply chain and stock trends are all possibilities due to the advancements in HPC. You would have noticed that HPC in many of these examples could be located in either the academic or industry space. HPC today can be found across all branches of government, academia, as well as a wide spectrum of industry and commerce. How these resources are shared is the topic of the presentation today. Colkin Riviera Santos in 2018 stated that the research output in Africa are low when compared with global trends and expectations. Although there has been a significant rise in publications since 2008, Africa's primary research output is dominated by the agricultural and life sciences field, with less input from physical science, mathematics, engineering, and technology researchers. One of the reasons for this is that Africa has very limited research facilities in terms of fundamental and applied sciences. Where there are such facilities, there are factors which hinder its full potential and utilization, including the initial cost of setting up the infrastructure, cost of subsequent maintenance, periods of inactivity while infrastructure needs to be replaced or maintained, and the possible abandonment of research facilities due to political agenda. Developing nations have long since relied upon international investments to support the implementation of ICT systems, such as a national education research network. In Ethiopia, the Ethiopian Education and Research Network was founded that focused on the development of a much needed ICT infrastructure for universities to share resources locally and globally. However, Ethernet has not yet connected to a global education research network. The current ICT facilities to support such research are insufficient, restricting the local research network. In 2007, South Africa saw the Center of High Performance Computing, or CHPC, established with the South African Research Network, National Integrated Cyber Infrastructure Systems, and the Data Intensive Research Initiative of South Africa that followed soon after. Egypt has its own HPC system within the Bibliotheca Alexandrina, whom many consider to be the new Library of Alexandria. Since 2009, the library has been providing resources to researchers through online databases, books, journals, or the organization of relevant conferences and events. It currently has a merit-based access system for researchers in Egypt, where they may conduct simulated experiments and processes. For this study, we made use of a systematic literature review. The parameters included any publications from 2000 to 2020, although we did not expect to see anything really before 2007. The research had to be conducted in the African context and had to look at the management and access of HPC resources and services. 7 articles were identified, but only 4 were included in the final study after we measured them against these parameters. The first study was from Ezel and Atkinson in 2016. Although the focus of the article is the USA, the Square Kilometre Array, or SKA, was briefly discussed in this paper. The SKA is a massive radio telescope comprised of more than 500,000 antennas spread out across vast areas in Australia and Southern Africa. Expected to be completed by 2024, the SKA will collect radio signals from outer space for a multitude of purposes, including better understanding the origins of the universe, monitoring for intelligent life, and understanding the properties of celestial systems. It will collect 14 exabytes of digital data per day when completed. While 15 countries are on the board of this project, the National Research Foundation is the participating organization in South Africa. The second article was published in 2018. The Center of High Performance Computing in South Africa supports this African School on Electronic Structure Methods and Applications. But there are other regional initiatives by groups in various parts of Africa that have, through their own governmental resources and support from international institutions, set up smaller HPC facilities. Computational science groups in Ethiopia, Ghana, Kenya, and Zambia have small HPC facilities that have been set up mainly by local resources, while the HPC facility in the Sudan was set up with the support of the Chinese government. In Kenya, the Kenyan Education Network is supported by a special interest group. The third article focused on Ethiopia's Ethernet. The research study was established, or has established, that HPC is influential in the quality and quantity of research and learning of it, which impact on Ethiopian higher education institutions, and is one of the crucial variables affecting the research output of these institutions. Researchers agreed that their network is unreliable when they collaborate with other scholars internationally. Also, the network hinders them when they want to access virtual labs and facilities like HPC. Researchers stated that the unavailability of the required research infrastructure, including HPC and remote access computing facilities, as well as training, are the main problems to conduct their research activities. To this extent, experience sharing could be explored with other global research and education institutions. The last article was from Moyaka in 2015 and discussed the CHPC in South Africa, including that there are 11 flagship programs and many students and scientists that are invited to learn from and share their experience with the scientific community in South Africa. After the analysis of these articles, the following were observed. All the articles were published in the last 5 years, which one would expect with a new technology. Most of the studies are descriptive. They don't analyze they're not analyzing the collaboration that takes place at HPCs, but rather discusses who the stakeholders are and the work that has been done. All the projects include collaboration or support between government and academia stakeholders, while half of the articles also mention some involvement of industry, although in a limited capacity. The reliance of HPC resources on funding from government contributes to their risk profile. These centers must become self-reliant to support infrastructure development. The development of both staff and infrastructure is an issue, as this is a new technology and field of study. As resources become available in Africa, staff will have to be trained on how to use HPC. Currently, the status quo is that once staff is trained overseas, they stay there and work in industry or academia. Very few return to share their expertise. System flexibility was only discussed in one of the papers, but this will be an issue in Africa with all the challenges to set up HPC resources. Flexibility will enable upscaling to more stakeholders in Africa for diverse purposes to make use of these resources. In summary, there is a lack on how HPC resources are accessed and shared among different stakeholders in Africa. We have the opportunity to use the mistakes of more advanced countries to leapfrog into a favorable position to use HPC for scientific discoveries in the coming years. However, the lack of literature on the topic has been established, and this means that there is a novel contribution to provide in this area. So the possible research title for the PhD study to commence next year then becomes an access utilization framework to improve academia-industry information collaboration. And we will specifically be looking at the national integrated cyber infrastructure. As promised, here are our details. If you would like to be in touch with myself or Professor Chinamarindi, if you'd like to contribute or follow our work, our contact details are on the screen. Thank you very much.
Thank you, Professor Cilliers. I haven't observed any questions in the Q&A box, but just from my side, it's very interesting to identify all the things that you've studied, because I'm involved in a project which is actually distributing HPC resources across Africa, and we actually target local universities in South Africa as well. So, typically we found that if a resource is offered for free, someone's going to take it even if they can't use it. But, that's half the challenge, is that sometimes you're allocating resources to the sites that perhaps aren't able to use it. And there doesn't seem to be any vocalization from the sites that do need equipment, because they don't necessarily know where they need to go to ask for the equipment. So, yeah, I guess that's an indictment from both sides, from the way that we advertise the equipment and also how people can actually put their hands up to say that they're desperately in need.
Yeah, I think that is a lot has been done on using the equipment and what can be done with HPC, but management and access and providing resources has not been studied as much. And I think the equipment and the infrastructure is out of reach for many universities and academia and all of that in Africa specifically. So we need to make sure that what we have we can sustain, and that we can share to the broader community to make sure that everybody has access to the resources that they need. Yeah, I don't see any other questions. So thank you very much for having us at the presentation. And we are looking forward to sharing our work in the future at the conference as well.
Yes, thank you very much. We seem to be well ahead of time. So the next session will start at 12:15. So that's 30 minutes from now. If you want to stay in the chat room and post comments, I suppose you can. I don't know if the chat room will remain open, but yeah, from this section, I guess we're done. So, oh, I've just got confirmation that it will actually remain open if you want to stay in and chat to anyone that remains. Otherwise, thank you very much and enjoy the rest of your day.
Thank you.
My name is Temba Tladrayo, and I will be introducing to you our two speakers for this session. Please feel free to use our Q&A functionality that appears on the bottom of our screens for any questions that you may have as the speaker continues with his talk. Without consuming a lot of time for the speakers, please let me introduce to you our first speaker, Mr. Gilad Sheiner, and I will read to you his brief overview of the background. Gilad Sheiner serves as Mellanox Senior Vice President of Marketing at Nvidia, focusing on high-performance computing, artificial intelligence, and Infiniband technology. Mr. Sheiner joined Mellanox in 2001 as a design engineer and later served in senior marketing management roles since 2005. Mr. Sheiner serves as the chairman of the HPC AI Advisory Council organization, the president of UCF and CIX consortiums, a member of IBTA, and a contributor of the PCI, SIG, PCIX, and PCIe specifications. Mr. Sheiner holds multiple patents in the field of high-speed networking. He is a recipient of 2015 R&D 100 Award for his contribution for the core direct in networking computing technology, and the 2019 R&D 100 Award for his contribution in the Unified Communication X technology. Gilad Sheiner holds an MSc degree and a BSc degree in electrical engineering from the Technion University of Institute of Technology in Israel. Mr. Gilad, please welcome to the platform.
Thank you very much. If I knew that you will read everything, I would make it probably much shorter. But thanks for the intro. So after this long introduction, I'm happy to virtually participate in the conference and talk about the Nvidia Infiniband networking technologies and also roadmap and the major things that are coming next. So first, Infiniband has become the de facto connectivity for high performance computing. It's becoming the de facto connectivity or the ideal connectivity for deep learning. We see more and more hyperscale cloud infrastructures leveraging Infiniband for compute and data intensive applications. The reasons for that, are actually based on the main fundamentals of the Infiniband technology. And there are four main fundamentals that are the foundation of Infiniband. The first one is a design or architecture of a very smart endpoint. An endpoint that actually offloads the entire network transport into the network. It's a network that manages all the network functions at the network level itself, which means CPU cycles and GPU cycles can be completely dedicated to the application work and not for networking related items. It also enables to bring acceleration engines, smart acceleration engines, compute engines into the network and actually participate in the job runtime, as well as doing smart manipulations or ability to do smart manipulations on CPU memories and GPU memories. The second fundamental is the switch network that was designed, spec'd to scale to the unlimited, in a sense, unlimited scale. Infiniband switches are very simple, very simple. If you look on an Ethernet switch, just an example, every Ethernet switch comes with a server board inside of the switch to run the operating system of the switch. Infiniband does not need any. That's what makes Infiniband much more cost effective than anything else. Some people look on Infiniband as might be more expensive because it's a network for supercomputers. It's actually rather the opposite. It's much more cost effective than many other options. And the same component, the same building block, can be used for small scale environment into very, very large scale environment. Same building block, very simple to build any sort of infrastructures. The third one is that Infiniband was born as a software-defined network before we actually knew what SDN is. That means that you can control the entire routing from a central space. You actually can control the entire fabric from a central space. You can build any sort of topologies. You can build factories or Dragonfly Plus or HyperX or Torses and other topologies and match a topology to the performance, to the desired performance, to the desired cost of a system and so forth. And the last and not least, Infiniband is a standard technology. Everything is backward compatible. Everything is future compatible. The same software, the design of one generation connect to the next generation. You can build system with multiple generations, and everything will connect to everything and work as one system. And that's a huge advantage. You know, we think proprietary networks come and go, and what you design or invested in one generation completely get lost in another generation. OmniPath, it's an example for that. The Slingshot, it's another example for something that doesn't really exist, but it's completely proprietary. And the strength of being a standard means that you have a huge ecosystem behind you. It means that whatever you invested now, you're going to continue and carry into the future. Now, if we look on the active components inside of a supercomputer, obviously we think about a CPU and the GPU as active components. The network has also become an active component. Years ago, the network was just an element that moved data from one side to another side. But that's it. So it was more of a passive component. Today, the network includes multiple computing engines that sits inside of the silicon devices on the data path and enables to actually do data manipulations or data arithmetics on the data as it moves within the network. And that was an important capability that enabled to migrate data centers from being very CPU centric, meaning you're running everything on a CPU, to be more of a data centric, which means that if you want to overcome performance bottlenecks, you want to move compute to where the data is, not the data to where the compute is. So today, Infiniband includes multiple compute engines that sits inside of the silicon that they actually can run algorithms, data algorithms, that is much more effective to run them on the network versus to run them on any other compute element. And there are two kinds of computing engines, so two categories of computing engines. One kind, it's a programmable element. There are cores. There are compute cores that sits inside of the networking devices that enables to migrate multiple algorithms or different kind of algorithms from the CPU, the GPU into the network or into the network. There are Infiniband devices with ARM cores inside of them. And you can migrate control path of applications. So you can migrate pre-processing of data. You can migrate infrastructure management elements. You can migrate security, isolations, actually do everything on a computer that sits inside of a network device. The other category covers pre-configured engines. Those are engines that are built for a very specific algorithm, which is commonly used, that's one thing. And then that running that algorithm on the network will give great performance benefits. Once you have computing on a network, you can actually take an holistic view on the applications, on the algorithms, and see which algorithm should run where. One example is algorithms that doing data reductions or data aggregations. Doing data reduction on a node, it's not the ideal place for that. Because once you do data reduction on a CPU, for example, you will need to make sure that you move all the data between the CPUs, and you can run in a ring topologies, you can build tree topologies, you can move data multiple times between nodes. And as more nodes you have, actually, the time it's going to take you to do that, it's increasing. So doing data reductions on the node, it's not the ideal place. But moving a data reduction algorithm and run it on the network, that's completely something else. Because the network connects to all of the nodes together. So the only thing I need to do is send the data from the nodes into the network. The network will do the aggregation in one phase and send the results back. And if I have more nodes, it's going to take me the same time. So now I can actually go to flat latencies. So reduction, the ideal place for running reduction is on the network. And that's what Sharp is doing. Sharp is the name of the technology that actually runs data reduction algorithms on the network. Npi Tag Matching is just yet another example. When I'm sending MPI messages, for every incoming MPI message, I need to interrupt the CPU, so the CPU will look on all the receive buffers and find a match, and then write the data to the right buffer. But if I move this operation and run that on the network adapter, for example, then I save the CPU interrupt. I can do direct data placement or do rendezvous and actually bring the data from the other side. And I'm sorry, and I'm not suffering from system noise and jitter. So great benefits. And probably maybe even more important is that by doing the tag matching on the network, I can also increase the ability of doing overlapping between compute and communication. And the more overlapping that I have, I can hide latencies. And then I can get applications to actually zero latency, which is a kind of holy grail of HPC. So those are examples of pre-configured engines. And of course, network is a network at the end of the day. And Infiniband is the only HPC network that runs 200 gigabit per second end-to-end for 2 years in production. RDMA, GPU Direct RDMA, GPU Direct storage, all the direct data placements, and adaptive routing or congestion controlling, quality of service, and ability to build smart topologies and so forth. A few examples, looking on Sharp, doing data reductions on the network, testing that were done on the Niagara supercomputer in Canada. Maybe it's still the fastest supercomputer in Canada to date as well. Running MPI all reduce on 1,500 nodes, 40 processes per node. So it's a total of 60,000 MPI ranks, reducing the time for running an MPI all reduce by 7x. But it's not just reducing the time. Once you do reduction on the network, you also reduce the data motion. You need to move less data. You reduce CPUs over it, or CPU utilizations, or GPU utilization in a sense. So there's great benefits for that. Running MPI tag matching on the network also reduces latencies. But it's not just reducing latencies, it's also, again, reducing utilization or CPU utilization. It's also enable overlapping between compute and communications. So those are great performance benefits that in-network computing or the computing engines on the network provides. Now, one thing that not sure that everyone is aware, beside of the network adapters and switches and cables to connect everything together, there are several other appliances or several other solutions that can help to bring more capabilities into Infiniband supercomputers. Starting from the left, Matrix, it's an appliance that enables to increase Infiniband reach, native Infiniband reach over distances, goes all the way to 40 kilometers. which means that if you have a remote Infiniband systems, you can connect them natively with Infiniband, pure RDMA, all of the Infiniband advantages, and actually build a virtual larger system. You can connect Infiniband to a remote storage. You can connect Infiniband cluster to another system for disaster recovery, for example. Or you might have scientists that wants to have a fast network or fast connectivity into the large supercomputer for fast visualization of their results. So MetroX or MetroX2, it's a great device that connects to the data center. It can run 100 and 200 gigabit Infiniband over long distances. The second appliance is Skyway. It's a gateway between Infiniband and Ethernet, 8 ports of 100 or 200 gigabit Infiniband to 8 ports of 100 and 200 gigabit Ethernet. Failover between the ports, load balancing between the ports. If someone needs more bandwidth, they can put multiple Skyways together, and there is load balancing and failover between the boxes as well. It's a 200 nanosecond gateway. So it's a low latency gateway, and you can connect between Infiniband and Ethernet. 10 years ago, we actually tried to move Ethernet all the way to the Infiniband switches as part of enabling gateway between Infiniband and Ethernet. And we had 2 generations of switches, Switch X and Switch X2, that actually you can connect standard Ethernet into an Infiniband switch. We decided not to continue with that. And the reason is that once you bring a standard Ethernet that comes with all of its baggage, all of the algorithms that requires to be supported on Ethernet, and you plug it into an HPC network, you're going to impact the HPC network performance. And by connecting the standard Ethernet into the Infiniband switches, we actually increased the Infiniband latency. And it didn't make sense. It doesn't make sense that we save an external gateway for Infiniband to Ethernet connectivity, and with that we increase the latency of the Infiniband network. So now all the applications going to suffer because there is higher latency inside of the data center. So that was a bad idea, and because of that we decided to separate. And there are separate Infiniband switches, which runs today in 130 nanosecond. It's like 3x lower than anything else that exists or will exist. There is nothing, no proprietary network, no Ethernet network that can reach the Infiniband latency. And that enables to have a lowest latency within the supercomputer. And then if you need to go to Ethernet, that's fine. Simple gateways, it's a 200 nanosecond, so you actually pay the extra latency there. And this is how you go to Ethernet. So it's much more effective. You can determine the bandwidth that you want to bridge between the one and the other. And again, you keep the lowest latency lowest latency fabric within the supercomputer. And the last and not least, it's the Ufm Cyber Ai. Ufm Cyber Ai, it's an appliance that brings the Ufm capabilities, which is for network management and orchestration and provisioning, but add an extra capabilities. Ufm Cyber Ai is a new product as part of the Ufm family of products. Ufm, it's not something new, and we have multiple appliances of Ufm that enabling or simplifying network management and orchestration. Ufm Cyber Ai includes all of the Ufm capabilities, but also adding some extra. So first, all the capabilities are covering network setup or simplifying network setup. Infiniband, it's already simple. Let's actually make it simpler. All the network management, upgrade software if needed, or upgrade firmware, looking on performance of the devices, and there is a health checking, connecting to job schedulers. It can connect to Slurm, it can connect to LSF, for example, it connect to OpenStack and other management utilities. But the extra elements on Ufm Cyber Ai are based on applying deep learning algorithms on telemetry information. The appliance includes a GPU inside. and includes a large storage inside as well. And it reads telemetry information every few seconds from the system or from the network, from the adapter, switches, cables, transceivers, and so forth. It's small pieces of information, so it doesn't really impact the performance of the system. And it builds an historical database of telemetry information. And on that database, it applies deep learning algorithms that are looking for anomalies. They're looking for performance degradations. They're looking for correlations or find correlations between temperature, spikes, workloads, usage, and so forth. And the outcome of that, it's predictive maintenance. It actually can predict potential issues in the future and give alerts for that. And that enables sysadmins to actually fix things if needed before they actually fail. And it's definitely helps to improve OpEx. The other part is that the Ufm Cyber Ai also learns the usage of the system. What are the communication patterns that are running, which you can correlate to different kind of workloads? How the system being used, typically. And then if there is an anomaly, there is a change in behavior, there will be an alert that will provide it. And with that alert, or that alert can indicate that someone is running a new workload that's maybe not supposed to be there, or someone is using the system in not something that was designed for. So now you can also get alerts regarding security in the usage of the system that can help to better manage the system. Now, at Supercomputing a couple of weeks ago, we were very excited to announce the next generation of Infiniband, which is NDR 400 gigabit per second Infiniband. The NDR family of devices include 4 elements: the adapters, 400 gigabit per second per port, supporting of PCI Gen 3, Gen 4, Gen 5, new in-network computing engines, new engines that migrate more of Npi, more of deep learning frameworks, and actually running them on the network. The DPU, the data processing unit, which incorporate the NDR adapter inside with multiple cores of ARM, AI application accelerations, programmable data path, and in-network computing engines, and enabling the next generation of infrastructures by offering the ability to migrate the infrastructure management, migrate security, migrate more of MPI or more of communication frameworks into the network, and using that to drive the next generation of supercomputing platforms. On the switch side, we have tripled the number of ports. So going to 64 ports of 400 gigabit per second, and each port can be split into 2 ports of 200 to up to a 128 ports of 200 gigabit per second. If you compare it to other HPC or other switches that might exist next year, this is 2x the bandwidth or 2x the number of ports. It means that you can build larger infrastructures with less switches, less cables compared to anything else. And of course, cables and transceivers, corporate cables, active corporate cables, and optical transceivers provide the full range of connectivity to build any sort of topologies. So you're not stuck to a given topology. You can actually build different kind of topologies and match the topology to the kinds of workloads that are going to run on the system. And Infiniband continues to set world records. Today Infiniband is the only 200 gigabit per second HPC end-to-end network. And with NDR moving to 400 gigabit per second, doubling the data speed. There are new acceleration engines, new in-network computing engines that will also migrate all-to-all operations and increasing MPI all-to-all by 4x. Increasing MPI all-to-all performance by 4x compared to what exists today. On the switches, we will build probably the largest ever HPC switch, 2048 ports of 400 gigabit per second for a total of more than 1.6 petabit per second of bidirectional bandwidth. It's a 5x increase in switch system capacity. And with the Radix, we can connect in a Dragonfly Plus and 3 hops more than 1 million nodes at 400 gigabit per second, or more than 200 million nodes in 200 gigabit per second. There is nothing that matched that. And definitely, if we're looking on the exascale generation and even beyond, it's completely exascale ready. And then from accelerations of AI, Sharp, the main technology that run data reductions on the network for simulations, for deep learning, is accelerating its capacity for AI accelerations in the network by 32x, making that the best technology for both high performance and deep learning applications. And of course, bringing all of those capacities and all of capabilities and comparing the same bandwidth to what can be done today, NDR Infiniband will also enable to reduce the total cost of ownership. So if you look at 1,500 nodes, it's a 1.2x reduction in cost and 1.2x reduction in power bill. And if you build larger systems, the advantage is even bigger. So as an example, for 4,000 nodes, we're looking at 1.4x reduction in the network cost, as well as 1.6x reduction in network power saving, or 1.6x network power saving, reduction in power bill. So if we combine everything together, Infiniband is the highest net speed that exists today. It's a 200 gigabit per second end-to-end, and it's extremely low latency. It's a 3x lower latency than anything else. Even things that are still on paper, it's 3x lower latency. And it's 3x lower latency because it focused on the Infiniband network. And if you want to connect to outside Ethernet, to standard Ethernet, the best way is to go through the gateway. It's a 200 nanosecond gateway, so you pay the extra latency on the gateway, not on the switch of the fabric, not of the switch of the network of the supercomputer. You paid it on the gateway. And then you can go to Ethernet, connect to Ethernet storage, Ethernet infrastructure, or any other outside Ethernet connectivity. You can connect natively to Infiniband storage, and there's multiple companies and multiple solutions with native Infiniband storage. Just to name a few, and sorry if I miss anyone, but Data Direct Networks and NetApp and Accelero, and there's multiple others, and sorry if I forgot the name, or didn't list all the names here, but there's multiple, Wake.io, it's another example. There's multiple companies with Infiniband storage to connect to. Metrics, increase Infiniband reach over long distances. The Ufm Cyber Ai that provide predictive maintenance and security into supercomputing. And everything in a network that it's very robust, very reliable, and it's a standard. Everything you do today, you know it's carried to the next generation. So with that, I thank you for listening, and I think I have 2 minutes left. So I will stop sharing my screen and see if there are any questions that I can answer.
I don't see any questions on the Q&A function. If there are questions, ladies and gentlemen, please post your questions in the next minute or so.
Yeah, and always, if someone has questions after the session, feel free to contact me, and I'll be happy to answer or help on anything related to building the most advanced supercomputing systems. Thank you very much.
Thanks, Gilad. Okay, ladies and gentlemen, our next talk will be exactly now in a minute time at 12:45. And it will be based on the budgets and allocations in HPC. And the talk will be delivered by our next speaker, Mr. Ian Negliwood, who is a product manager for Alt-A PBS Works. Just to read a brief background about Mr. Negliwood at Alt-A. Mr. Negliwood has supported Alt-A HyperWorks where knowledge of desktop and HPC application tuning is critical, and managed Alt-A's UK HPC footprint. He moved into workload management with Alt-A PBS Professional 15 years ago to support, implement, and architect customer solutions for major customers. After a period in sales, he transitioned to product management to bring his breadth of knowledge to bear in mapping customer requirements into the software development process of Alt-A PBS work suites. Ladies and gentlemen, please let us welcome Mr. Negliwood if he is ready to start with his talk.
So at a high level, what are the capabilities of budgets? Well, most importantly, we need budgets to be a secure tool. So we only provide access to authorized users, and we have a role-based permission model to ensure the system is secure and the credit flow process is secure within the system. The budgets tool allows us to define, allocate, and control budgets for what we call groups, but that could be used for departments, businesses, and accounts, which are typically projects with a list of member users, but can also be individual user accounts on the system. The key thing being to ensure that only authorized users can consume credit, and in fact, only authorized users can provide credit into the system. From a user point of view, credit consumption is fairly transparent. Users submit workload as they would have in the past, and that workload then consumes credit. If there isn't credit available, the workload can't run. And then finally, having provided and consumed credit, an organization needs to report on that credit. So whether that be groups, departments, or individual accounts, we can provide reporting for budgetary periods either on a summary basis or on a detailed transactional basis. One of the key focuses of the tool is that the credit management lifecycle is secure, and there's a lot of aspects to that. But I'll just pull out a couple of important things for most of our customers. The first being that we have a really good credit lifecycle. I'll talk a little bit more about that later. That really defends a site from accounts going overdrawn. Which is obviously really important on the system. We also have a process where refunds can be provided, and you can imagine various scenarios, but the sort of common scenario is you've got a multi-node job, it's been running for several days, and a node failure causes that job to crash, and then it needs to be rerun. It may be that the internal customer, the user, feels that they shouldn't be charged for that job, so they can request a refund. And only an administrator can provide refunds because it has to be somebody who can investigate the problem with sufficient knowledge to make a judgment on that, and then a percentage of that job could be refunded, but no more than the original consumption from the job. And then just a little more on the user experience. To use this system, if you're using project accounts, then a user needs to specify which project they'd like to run their job on, the resources, and the time the job will run for, because credit consumption's typically on a time basis, but otherwise there's no change on that side. Just to look a little bit at the data structures and workflows to make it a little clearer how this tool works. First thing we'll just look at is the some of the key data entities in the system. So we can see at the top left here we've got what we call service units. So they're the currencies within the system. And you can have one or more of those currencies. So two models that we see are one where a site might have CPU hours and GPU hours. And every job consumes CPU hours, but only GPU jobs consume GPU hours. And that's a way of then controlling access to GPUs, because you can control who is given GPU hour credit. You could also have a single complex model that was, say, dollars, and that could be the sum of the dollar cost of CPUs, GPUs, cloud nodes, any entities you want, simpler or complex formula as you like, including logic as well, to capture your business model for that. So that's sort of the classical service unit, where we provide a credit pool. That credit pool is consumed, and when it's gone, an account can't run jobs until further credit is provided. But we also have what we call a quota service unit. And the classical example there is a storage quota. So it may be that a site has multiple different data storage systems, and they want to control the overall consumption by projects and users on there. So a quota can be allocated to an account, whether that be a user or project on the system. The site would then provide a script that feeds periodic updates on consumption of storage into the system, typically in gigabytes currently, but that's completely a site's discretion how to calibrate that. If an account is over quota, they can't run jobs, and then when they go under quota, obviously they can. The nice thing there is that encourages good behaviour of the user community, because they can fix that themselves by archiving data, compressing data, deleting perhaps failed jobs and things like that, and when the next report comes in, their jobs would just automatically start running. So it encourages good behaviour and has minimal admin input. The middle entity here is time periods. So we have budgetary time periods that allow credit to be allocated to a time period. So you might have 2020 as a time period. You can also nest periods under that. So you could have 2020 Q1, Q2, Q3, Q4, and even under that you could have the months if you wanted. It can be as simple or as complex as you like at that level. And you can also apply funding to all those tiers, and the system will start looking at the lowest tier and work backwards through the structure to find credit for a particular job. And the final core entity in the system is clusters on the right here. So you would add the name of your PBS servers here, which would allow that server to connect and use this system. It also allows you to deactivate a system. So if you're wanting to shut down a system for some reason, you can deactivate credit consumption on that system, and that will stop new workloads running. Equally, you can do that in the PBS server, obviously. There. Then the central tier here, users and roles. So we would define a set of users on the system, and these would just be your typical user names. I've got some sort of illustrative names here where we've got admin 1, investor 1, manager 1, user 1. Each of these would have a role associated to it, and we can see the different roles here as well on the right, where we have admin, investor, manager, and user. And there's a left to right inheritance as well. So an admin is also an investor, manager, and user, and a manager is also a user on the system. And that can be really important because you can have a project manager in the system who's also running jobs and consuming credit in there as well. There is also an additional role called the teller. That's the trusted banker in the system, and that is solely used by the internal processes for managing credit transactions. Shouldn't be used for any other purpose. So then how does that manifest in organizational structure? So we have various accounts that can hold credit. So on the left here we have groups. They're used to reflect organizational structure. So it could be that you have different divisions. Each division is a group. What is important about groups? In this example, we've picked out a function within the organization. So engineering. Engineering has one or more investors that can invest into that, and investors are really a top-level CFO type person who can provide credit into the system. So they're really a high-level user. And then a group also has a set of one or more managers, and those managers are the people who can take that funding and provide that down to the lower level accounts. And the lower level accounts are shown in the other two boxes here, so that would be users and projects. So users can optionally also hold credit on a system. If they don't hold credit, they can't run jobs under their own user. So it's it's a choice that you can make using the system. And then the most common vehicle for providing credit is a project account. So a project account would have a set of clusters that it can use. That might be all the clusters you have available, or it might be a limited part of the community. It would have a list of users that are part of that project, and only those users can consume that credit, that account's credit. It would have a list of one or more groups that could invest in it, so you can have a co-investment model into projects as well, and only those groups can make investments or withdrawals from that project. Any entity that consumes credit, so both users and projects, have a billing policy, begin, end and proportional as listed here. This is only really valid where a job runs near the boundary of budgetary periods. So if I have a job that starts on the 31st of December 2020 and it finishes on the 1st of January 2021, do I bill the period it started in, the period it ended in, or bill proportionally across those two periods? That's tunable. And then the final thing that exists here is the actual credit. So in the case of an account, that is an investment that's come from an investor into a group, and then a group manager has passed funds into the project, and that will manifest as a credit in the locally defined service unit. So we're just using the default one here of CPU hours, and we have an investment of 723,000 into the period 2020. We also have a storage quota of 1 terabyte for that project as well. So if they go over that, they would stop running. So those are the data entities that we can use to define our structure. In this slide, then we can see what that structure might look like in a more illustrative way. So globally, we have a PBS admin who's the defined administrator. So during installation, you actually define a single user that's the starting administrator. They can define other administrators in the organisation, but in this case, we just kept the one. They then define the users, groups, and projects in the system with the relevant members. So in the case here, we've got defined Matt as a user with the role investor, then the group engineering who has Matt allocated as an investor to that particular group. If there was many investors, it could be a limited part of the community. In this case, of course, Matt's investing in all the available groups. A set of managers, and then under here we've got a project defined with a set of users that is a member of actually engineering and research groups in this case. And that, what we can see then superimposed here is that Matt has invested 85,000 CPU hours into the group engineering, and then Ian as a manager has invested 25,000 CPU hours into the project one. Users Ian and Brian can then run workload and consume that credit, which is actually 35,000 in total, because Scott has also invested on behalf of research. And then if we just look over to the two columns here, we've got the steps that are required to create that data structure. So we would create our user community, add the groups, and then create projects with the appropriate groups and users. These can be done out of order and group. Obviously, we have a full command structure for creating, deactivating, updating these entities, and updating can be adding and removing members from any of the associated lists. Once that data structure is in place, then investment flow can take place. So organizational structure is really the administrator's world. Investment flow becomes a combination of the investor, so Matt here investing into the two groups, and then the manager roles passing that investment down from the groups into the accounts, and finally the consumption of that credit via workload. So that gives an idea of the purpose of the tool, the data entities we have available, and a sample data structure to illustrate that view. How then do we manage that in the context of a job life cycle? In this example here, we've got a user who submits a job to a given project, requesting some resource and given wall time for the job. When they submit the job, the budget system validates that the project they're requested exists and that they're a member of that project. It also validates that they're allowed, that project is allowed to run on the particular cluster, and optionally it will validate credit and quota. Now that is optional because many sites would rather workload went into the system, and if it's not able to run, the user can request additional funds. When the funds arrive, the workload will just start running by itself. There wouldn't need to be additional actions. Other sites would prefer that the workload is rejected from the system and doesn't sit on the system, and so that is optional. So in this case, we'll take it that all these criteria are met and the job's accepted into the system. Once that workload once PBS decides that workload can run, we would then revalidate these checks. So we validate the project, the user, because while the job sat in the queue, the budget configuration might have been changed. The user might have been removed from the project, so they may no longer be eligible to run on the system. So we re-perform that check. We then check that there is sufficient credit for the job, and that's for the maximum envisaged run time of the job. And we take the credit that we calculate for that, if it's available, and put it into escrow. So we put it into a holding area in the system, so it can't be consumed. And this is one of the key mechanisms for stopping accounts going overdrawn. And then optionally, if we've provided defined any quota currencies like storage, we would also validate those. All those checks pass, the job goes to the execution host and runs. When the job completes, then the system calculates its credit consumption and tags the job with that consumption, and the job exits from the system. And then finally, there is a periodic process that runs, it's tunable, but typically every couple of minutes. And that periodically checks for completed jobs and reconciles those jobs off in batches. So the reconciliation process takes the reserve credit from escrow, moves consume credit to the debit side of the table, and returns unused funds to the relevant account for further usage, and that provides the entire life cycle. If we do have quota currencies, then there is also a separate process running where a site-defined script would periodically update the quota consumption for each account. and you know, that could be storage, it could be anything really a site would like to use there. And with that, then I'll move through to doing a quick demonstration of what that workflow looks like in practice. Thank you. So here we're just going to take a very quick look at the investment flow in the system, and then credit consumption via a job. So first thing I'm going to do is switch to the user Matt, who is our key investor, and then I'm going to log into the budget tool here. I then want to make a deposit in the system. And I'm going to make that deposit into a group that is called engineering, and that is going to be in CPU hours, and I'm going to add 100,000 of those, and that is the process completed. I can then run a report on that group to see the current state of funding in there, and we can see that currently there's a net balance of 350,000 because there's been previous credits and debits. And if I look at a more detailed report, we can see that history. So there was an original investment of 500,000, the subsequent one I just made of 100,000, and 250,000, sorry, has then been passed through to a project. So we now have investment in that group. I will now switch users to Ian, who is a manager of that particular group. Again, we'll just log into the system, so we're authorized to make transactions, and then again we'll make a deposit, in this case to a project. The name of that project is Project 1. We're going to do that for project funding exists in specific time periods, and in this system we have time period 2020. We also have to define which group the funding's coming from, because a manager could be members of multiple groups, so we need to be explicit about that. And then finally, the currency and the value of that investment. So we'll just invest 50,000 hours. And as we'll see there is a typo. So that group doesn't exist. If I correct that, we can see that that has gone through. And again, I can now run a report on the project and see the state of funding, including the detailed transactions, and we can see the grant here in that case. So Ian is also a member of Project 1, so he can also run workload. So if I just go back to my summary report here, what I will do now is run a job. It's just a simple sleep job. It asks for 10 minutes of wall time, actually only runs for 1 minute. If I do a QStat here, we'll see that job has already started running, and if I run a report, I can see that additional funds have been authorized for that particular job. We can see previously there was just funds authorized for a different user's job. Now we've got additional funds authorized for that job. When that job completes, consumed credit will go into the debits fund, and unused credit will be returned to the net balance for use later. If you just look at the contents of that job while it's running, we'll see the only real change that we have to make here is that we specify the project we're running in. If we're not a member of that project, it wouldn't allow us to run the job. If we are, of course, and there are sufficient funds and all the other checks that we discussed earlier pass, then we can run that job. Job's now completed, so if we now look at the report, what we can see is that actually the job's completed, but the reconciliation process hasn't run yet. If you just wait a few more seconds, that process will run and those funds will be returned. And we can see that now. So we can see that the net balance has actually gone up now. Some of the funding's been returned and the debits has also increased. And that's a very quick view of funding life cycle and credit consumption in the budgets too. Thank you for attending.
Thank you, Mr. Negliwood, for the presentation. Ladies and gentlemen, Mr. Negliwood has apologized for the quality on the slides, and he has sent us the link. You can check the link on the chat box. Okay, it is now the time for Q&A session. And I have one question from Nkwe Monama. He asked, how do you deal with projects that have different ending periods? That is, periods that expires at different dates.
Yeah, thank you, Themba. Yeah, as you mentioned, apologies for the quality of the video there. I've posted the link to where you can get to a high resolution version. In terms of the project question then, and having different ending periods. So projects by default are created open-ended in the budget tool, so they run forever. And then optionally, you've got the ability to apply a start and/or an end date to those projects. So once the end date arrives, then credit within that project wouldn't be able to be used. Of course, if somebody applies for an extension to their project and that's granted, the expiry date can be updated and the project become active again. And as projects own the expiry date, they can all have, every project on the system could have a different expiry date, and you can, so I think the framework's there to manage that effectively.
Thanks, Mr. Negliwood. I see there are no more questions directed to you. Thank you very much for presenting the talk.
No problem, thank you.
Okay, ladies and gentlemen, our next talk will start at 2 o'clock. So this room will be closed for now, and you are welcome to join the session again at 2 using the event platform that is sent, the link that is sent on the event platform. Thank you very much for attending. Bye-bye.